Hey guys, Jesse here. I think it's every bladesmith's dream to create large, beautiful pieces that push their skill set and creativity. The only problem is that it's not really up to the bladesmith, it's up to the client, and not everyone can afford such high-end, time-consuming work. I was recently talking with a client that expressed interest in a chef's knife of mine, but having made several already this year, I had to decline. Surprisingly, he responded saying that he'd be happy with any piece, and he also said this: price really isn't an issue. After the shock wore off and I thought a little bit, I pitched to him a massive Bowie knife in a complex Mosaic Damascus, a new handle construction I never attempted, and a matching near indestructible leather sheath. His response was pretty simple: yes. And so I got to work. The premise that I had for this Mosaic Damascus pattern was that I wanted to combine mini explosions with some big bright stars. For my first billet, in order to help create that mini explosion, I took some 1084, 15N20, and then I alternated them. One of the special sauces that I threw into this initial billet was I doubled up on my 1084. This would make it so that the bright bars would seem brighter because there was more dark. I moved the garage door. This is another one of those special sauces that I've been using on my pieces for the last 2 to 3 years. I'm basically dipping the billet in Quench oil, and then the oil burns off and protects the billet from oxidizing. It's basically like using flux, but it's a lot less aggressive. The machine that I'm using is called a hydraulic forging press. It can output around 25 tons, and it's really the most important tool in my shop. One way to put it into perspective is that if I were to forge down a billet of this size by hand, it would take me a couple days, but with the forging press, it'll take me 20 minutes. I should probably re-weld these dies, they're kind of sketch. The next step in making this pattern is I'm using these squaring dies here to sort of pull the outside of the billets down more than the center. This will make it so that the bars in the steel will become curved, like C's. One of the new things that I tried to get a little more activity in my Damascus was I used the flat dies to smear the pattern even more. I wasn't 100% sure if it would work, but I was confident in my forge welds, so I went for it anyway. Oh, half plus a quarter. I'll go 3/4. The plan for this billet was to cut it into only 3 sections and then stack it and weld it again. I didn't want to do more because the mini explosions, I wanted to have some boldness. If I went for too many layers, they would sort of wash each other out and be too fine to see. I made sure to sketch out every single forge weld so I would know what to expect for the future patterns. Even though I'm only one forge weld in, I wanted to test touch the pieces to make sure everything looked right. Okay, I know what to expect, but I'm ready to be surprised if it's not. Okay. That is almost perfect. I really like when the C's are like slightly boxy, because then that gives like more flamey. We're at this step exactly right now, and it looks exactly like I drew, but it's in steel. So that's pretty good. To ensure that my next forge weld takes perfectly, I use the surface grinding attachment on my grinder to clean the pieces as best I can. This went pretty well for the most part, but there were some small delaminations that I needed to get out with the side of the grinder. I'm pretty sure these came from the inconsistencies of the thickness of the steel, even though I ground it down. I think there's probably a thought that's running through a lot of your guys' minds right now. If you're making such a massive Bowie, why are you making so little steel? And the answer I have for that is that I'm actually going to be adding fresh steel later on around this billet. Those fresh layers will end up becoming the stars, and these layers right here are going to become the explosions. This forge weld is a bit of an intermediate forge weld, so I'm not going to show too much of it, but all I had to do was draw it into an 1.5 by 1.5 square bar. Okay, I miscalculated, and this is definitely not 4 inches long. So what I need to do is I need to cut new steel that's 7.5 inches long, and I'm gonna sandwich this in between the pieces and throw those back in the forge. Okay, on each side, I'm gonna do just alternating dark light, dark light. One of the cool things about making Mosaic Damascus is that if you make one small change super early in the process, it'll compound after every single forge weld and you'll get a much cooler pattern. What I'm doing is actually really simple in the grand scheme of things. There's wizards out there like Bob Kramer and Salem Straub that can make incredible things with their Damascus, and I'm basically just scratching the surface at this point. I thought I wasn't going to have enough steel, but now I think I'm going to have the most steel I've ever forged at once. It's actually kind of scary to forge weld long billets because you can't get contact along the whole thing as fast as you could with a shorter billet, but it actually took pretty well. I have really wide dies so I could hit the first half and then the second half pretty much back to back. If you have good memory, you'll know what steps I'm going to be doing to this billet later. I'm not just going to be drawing it out and stacking it, I'm actually going to be rotating it 45 degrees and then re-squaring it. This does more than just tilt the pattern 45 degrees though. It actually adds a nice level of distortion to the center of the billet that sort of radiates outward, and it'll look really cool in the final pattern. To help ensure that I was holding the billet exactly diagonal, I used a trick that I saw Kyle Royer use on his channel. I flattened it fully on one of the axes, and then I tilted it and did it on the other. I didn't only just learn this trick from Kyle though, I actually got a lot of inspiration from this pattern from him. I think he actually twisted his billet later though, and I'm not going to be twisting mine, but nonetheless, I still got the inspiration from him. .2 divided by 4 is like 4.54. The next step for this pattern was to cut the billet into 4 separate pieces and then do a 2x2 weld, also known as a 4-way weld. According to what we had on the whiteboard, this should look like the corner of like an explosion. Oh my! Compared to my drawing, it's a little different. This section right here is a lot thinner because these layers, this distance right here should be the same as this distance right here, but my center is bigger. So now that this is smaller and these are bigger, like the diamonds are gonna cut in a little more, which is fine. I think it'll look still extremely cool. One of the things that I could use instead of the surface grinding attachment to grind these pieces is actually my new mill. But the thing is, I would have to get the scale off anyway because the carbide doesn't really like cutting the scale, from at least what I've read online. I need a fast way to remove the scale that doesn't create more dust. I know there's ways of doing it that take a couple days, like with vinegar and such, but I don't have that sort of time when I'm working with stuff like this. I also need the method to not create more dust. I could use an angle grinder, but then I'm just covering the other half of my shop with dust. If you have any recommendations for something like this, please let me know in the comments. I read all the comments, so don't worry that I won't see your suggestion. With the billet welded together, it was time to get ready for the 4-way forge weld. The only thing that's really different about this forge weld is that I take them to the scoring dies first, not to break in the corners like I did with the C billet, but so that I can set the welds on all 4 pieces at the same time. If I were to use the flat dies to set this weld, I could blow my billet apart sideways. That's because I don't have anything pushing toward the center. But with these scoring dies, I can put equal pressure on all 4 pieces, ensuring that I have a really solid forge weld, especially at the center. One of the things I was happy about here was how square I could get my corners. It's extremely important to have them be square so that you don't have any voids that you need to fill. Each one of these could be like a hammer by itself.
Oh! Oh my gosh! Holy dude! Wait, this is the best pattern I've ever done.
I don't know what I was really expecting when I was pulling it out of the test etch, but I didn't expect to see an exact copy of what I drew on the whiteboard. I'm not really sure what I did differently this time as opposed to the other times I've done mosaics, but I'll take it. If I had infinite time for every single forge weld, I would do what I'm about to do here. I'm going to be using my MIG welder and running across every single seam, making sure that oxygen has no way of getting into the billet. This is sort of like dipping the billet in the quench oil, but all-encompassing and mechanical as opposed to just a small layer of soot. The welds that I put on the billet were a little bit thick, so I took them over to the grinder and ground them down most of the way. This step is pretty important because later I'm going to be angle grinding the MIG weld off the piece so I don't contaminate the piece with mild steel, and if I leave them thick, they'll push themselves deep into the billet, making them harder to grind out later. What type of mine? that bad. What about here? 190. 190? In my last video, I talked about how my angle grinder was causing a lot of vibrations, and a lot of you gave some pretty good advice. The first one was to just get a Metabo, but I didn't have time to get a Metabo yet, so I got some different angle grinding discs, and it reduced the vibrations pretty much completely, so I'm really happy about that. Rather than going for a square cross-section like I do for my 4-way welds, I needed to go for a rectangular cross-section here. There's really no ideal tile size when it comes to tiling out the mosaics later, but the dimensions that work for me really well are about 1 inch by 1/8 by 1 3/4 inches. It was extremely important at this stage to get a billet with the exact same dimensions going from the base to the tip, and in order to do that, I use a really weird angle on my press. This right here is a bucket of a substance called vermiculite. It's extremely good at keeping temperature in, which means the billet is going to cool really slowly, making it really soft. You're probably wondering why I made so much steel. Look at that. Oh my god. I think this is probably the coolest pattern I've ever made. It's like perfectly lined up too. It looks so good. So right now the pattern is basically just going straight through the bar. If I were to make a knife directly from this, it would look no different from random pattern. So I have to cut tiles and turn it outward. And then once I forge weld them together, it'll look like the pattern is going across the entire blade. The tiling process is the most difficult step of making Mosaic Damascus, and it's also the step that kept me from making it for the longest time. I only got comfortable making it after I got myself a nice horizontal bandsaw and a surface grinding attachment. I think I want thicker tiles for this one. You know what? I'm gonna do it. I'm gonna go 3/4 of an inch thick. Along with my mill, I got another cool new tool that I haven't shown yet. It's something called a disc grinder. The disc grinder is perfect for getting things super flat, super quick. And with how important that is for putting tiles of Damascus together, I was really happy to have it. It's definitely possible to weld together the tiles without any protection on the outside, but the key word there is possible. I want it to be 100% success, and using sheet metal on the outside has historically led to that. So I can't just do something where I just lay them all flat like this, because that wouldn't look super consistent. I have to do something called like a fairy flip or whatever, where I turn this way, and because these two faces are mirroring, I make them go like this. And then I turn the 3 like this and continue the mirroring pattern. That way I have a perfectly continuous pattern running across the entire blade. That last step might be a little bit hard to visualize if you've never made Mosaic Damascus before, but trust me, if you don't do it, the pattern is going to look really, really blocky as opposed to flowing through the entire blade. All I'm really doing here is I'm using my MIG welder and I'm tacking each of the tiles to one of the sheet metal pieces. I have to keep in mind that there should be 0 air gap in between each of the tiles. Any space is room for a weld flaw, and I really don't want that, considering how long it took to make these tiles in the first place. With everything tacked together, it was time to tack on the other side of the sheet metal and then get ready to wrap every single weld seam with MIG bead. I only just recently got my MIG welder, and I used to work with the flex core, and I can say for certain, using the MIG welder felt so much cleaner. This entire process of welding around the entire billet took quite a while, but it's definitely worth it in the long run. In fact, I take it one step further and I dip the already fully welded billet into the Quench oil, just for that one extra layer of protection. Before I do this forge weld though, I think I want to give a special shout out to today's sponsor, CyberGhost VPN. With over 38 million users worldwide and over 20,000 excellent reviews on Trustpilot, CyberGhost is one of the best VPNs out there. So, why do you need a VPN in the first place? It's actually trivially easy for someone to come and see what you're doing online, and even incognito mode doesn't prevent that. Your ISP, your landlord, your school, even your home Wi-Fi router, they can all see what you're doing online. Personally, I enjoy having some bulletproof privacy, and that's where CyberGhost VPN comes into the picture. Using CyberGhost is actually really simple. All you need to do is press the power button on the application, and CyberGhost will automatically connect you to the best server in their network, encrypting and rerouting all of your traffic. This way, no one will even know anything about your online activity. CyberGhost also unlocks geo-restricted games and other content from streaming platforms such as Netflix, Disney Plus, and even Prime Video. And I didn't know about this one before, but CyberGhost can even score you better deals online by changing your virtual location, and that's pretty cool. It works on all major devices and operating systems: Windows, Mac OS, iOS, Android, you name it. And you can also protect up to 7 devices at the same time with the same plan, which means it's perfect for friends and family. With my link in the description, you can get 84% off a 5-month plan for only $2.03. That's the biggest deal I've ever heard of, especially in this economy. But yeah, I highly recommend you check them out, and massive thank you to CyberGhost for sponsoring today's video. And now back to forge welding. I took some really light presses on the first pass just because I didn't want to have any chance of blowing the billet apart. The MIG beads hold everything together, but I still didn't want to risk it. When I was super confident in my forge welds, I took the billet over to the post vise and I began angle grinding through all of the MIG bead on the side. It's super important that I do this step now, or else there's a chance that the MIG bead will push itself into the side of the billet, making the edge of the steel mild steel. The new angle grinding disc basically gave 0 vibrations, but it also disappeared in like 5 minutes, so I had to take the billet over to the belt grinder and grind it all out there. With all of that gunk ground off the outside of the billet, it was time to actually start thinking about forging my blade. But first, I had to blank out the billet and get it to a uniform thickness, and that's what I did there with the stop block.
Perfect welds, let's f***ing go. Not a single, even minor D-lamp.
This is the first time that I've ever forged out a Mosaic billet that hasn't had any D-lams at this point. I think it's definitely because of the MIG welder, but there's a chance that the thicker tiles might have also contributed to this. But yeah, what I'm doing here is I'm just cutting off the handle so I can start forging in the tang of the blade.
That's my tang, this is my tip.
This weird looking conglomeration of dies is actually essential to forging the shoulder on my piece. It's sort of the same thing as the half on half off technique where you create a shoulder on the anvil with the hand hammer. Except it's not a hand hammer and it's 25-ton hydraulic press, but it still does the same thing. Right here, you can definitely see the first blunder that I made during this project. I should have cut off the very ends of the billet and not left the sheet metal overhanging. It led to a lot of delaminations that I would have to deal with later on.
Oh my gosh, look how disgusting the end of that tang looks. All of the sheet metal is starting to peel up, but that's fine.
When I was satisfied with the shape and the length of my tang, it was time to start working on the blade, and that meant working on the tip of the Bowie first. The Bowie that I was going for was going to be around 15 to 16 inches long, which is kind of crazy. The piece that I had was already 13 inches long, so I only needed to get 3 inches, but 3 inches is kind of a lot. Technically, the best way to make a blade with 0 mosaic distortion is to forge a long blank and then to stock removal everything in, including the profile. But I'm a bladesmith and not a knife maker, so I was going to be forging.
How much length did I gain from just that? Oh, we gained a full inch already.
When it comes to gaining length in my final piece, there's a few things that I gravitate towards. One is to forge the tip longer, and one is to just go to the press and thin down the entire thing. Thinning down the entire blade can be kind of scary if you don't have enough material, but that's one of the reasons why I went so overboard with my tiles. That way I had a lot of steel for this process.
14 3/4 already.
To get that last little bit of length in my blade, and to start forging out the cross-section, I was going to be forging in the bevels just a little bit. I didn't want to forge them too closely to the shape because this is another one of those things that can lead to pattern distortion, and it can also make it harder to align everything later on. You're about to see one of the things that's kind of annoying when using a press to take down the thickness of something, which is if you forge bevels, the spine will be the only thing that gets compressed, so that's why that big curve there appeared. Yes, this process sort of destroys the cross-section I get from the bevels, but it's really not too big of a deal when I already know that I'm going to be surface grinding everything later on.
I think I accidentally made a sword.
When I was happy with the length of the piece, it was time to straighten it out and get it ready for some normalizing cycles.
This thing is so heavy.
I've heard other knife makers describe the normalizing as basically hitting the reset button on the steel. Normalization is 3 cycles of heating and cooling at 3 very specific temperatures that I'll put on screen here. These cycles reduce the grain size of the steel, making it stronger, and it also reduces the stress inside the steel. That way when you go to the quench, you won't get a crack, and you'll actually get a nice harden. With how thick this thing is, I'm willing to bet it almost weighs 5 pounds. Yeah, it's 3/8 of an inch thick.
You know what? I thought it would be way worse. That's actually not too bad.
This step that I'm doing here is called profiling the piece. The best way that I can contextualize and explain what this step does is that the blade coming out of the normalization is essentially blurry. You're looking at it without your glasses. Me doing this profile grinding is gonna help it look a lot sharper, and I'll explain it more after the heat treat with a cool demonstration. But yeah, after the light profiling, it's time to start surface grinding off all of the mild steel cladding on the outside. And I can actually check this by taking the blade in for a test etch.
Okay, let's see how this is.
Obviously, I can't spoil the pattern this early into the video, but just take my word for it, it looks pretty cool, and all of the mild steel on the outside is ground off. The last thing that I had to do before I put the blade into the oven for the quench was I wanted to take off a little bit of material off the edge. This doesn't really have to be done, but I didn't want to have to grind through an entire rectangular plate of material after heat treat. Right now the steel was pretty soft, but after heat treat it would be twice as hard. Before I go into the quench, I break every single corner with the slack belt on my grinder. This is a secret sauce that'll help reduce the chance of the blade cracking in the quench by reducing hot spots.
Okay, this is only extremely stressful.
It was a little bit chilly in the garage, so I used my blowtorch to heat up my container of oil. Hot oil actually quenches the blade faster than cold oil, so this step is pretty important.
Wow. Wow, straight. See if it's hard. Oh, it is hard. Hopefully this fits. It does not fit. Okay, that's good enough.
Out of the temper, the blade was not quite straight, so I was using my carbide ball peen hammer from Nyrock Tools here to straighten the entire blade. I like this a lot more than heating it up and bending it because it just feels safer.
Get in there. It's slightly out of whack, but I think that's due to the blade thickness inconsistencies. I think overall it's pretty damn straight. Look at that.
When the blade was straight, it was time to blue back the tang. This is basically reducing the hardness of the tang so that it wouldn't become a point of weakness later.
That blue is insane. Holy sh**.
So right now it's almost profiled, but it's not completely profiled. and the shadow, it looks okay. But there's some inconsistencies near here and here that once I fix, it'll look like a lot nicer. Like if your knife doesn't have a good shadow, like a 2D profile, it's not gonna be a good knife. Like I'm sorry, if you make it out of the most complicated Mosaic Damascus and your profile looks bad, it's not that great of a knife.
At this point, I don't even know if that's really considered a hot take in the knife making world. In fact, I don't really even know if hot takes exist. Everybody is sort of so nice to each other and don't really try to call people out too much with their takes. With my blade shape finalized, it was time to clean up those really precise lines in my ricasso area. And the ricasso is that little piece of blade that sticks out in front of the tang that's not actually the blade itself. Scribing lines like this is definitely one of those things that help me level up my knife making. Before, I would just eyeball things, and even though that probably helped me with my understanding of knife profiles, it didn't create the best product. It didn't create a pristine product. Now that I do scribe my lines, it helps me visualize what I need to do a lot more, which is really good. The final step of this grinding process is to actually thin down the blade and get my final bevels ground into the blade. This step takes the longest, and it's also the step that requires the most focus. If I'm not careful here, I can overheat my edge, making part of the edge soft, which is no good. I can also grind too much on one side as compared to the other, and even though the scribe lines help with that, I still need to continually look at it from the base to the tip. I think this step is the step in the knife making process that I would consider the most wasteful. If I were to cut off the slabs that I'm grinding off right now, I would have Damascus that I could use for other stuff. But instead, I'm using the grinder and I'm essentially turning that really nice Damascus into dust. This used to actually bother me a lot when I first started making knives, and I tried to save as much material as I could, especially for my handle material. But nowadays, I don't really consider it as much of a waste, I just consider it a step in the process. With the blade bevels 80-90% there, I'm going to be using a tool called a file guide to clean up the transition between the blade and the ricasso. It's called a file guide, but I'm not going to be using a file at all. I'm not a masochist. I'm going to be using the grinder and putting it right up next to the file guide. This might look scary for the file guide, but the faces are actually made of carbide, the same stuff that I use to scribe lines in my steel. So the belts can't touch it at all, it just glides off. I want to hit you guys with a question. Who makes a more perfect knife, a human or a machine? And the answer to this is actually the human. Knives can warp in the process of grinding, and if you throw a knife in a CNC, they won't know that it warps, and then at the end you'll come out with a warped knife. A human can see these and they can fix things as they come up, but a machine can't. And that's why most knife making factories don't use just machines. They use a combination of humans and machines.
So there's actually a pretty cool trick that you can use if your belts are glazing over. Like this belt right here, I just got it. It's a new belt, but it's starting to not cut as well. It's glazing over. What you can do is take some carbide that you're not using and just grind it, and it'll reopen up the grits.
There may be some of you without carbide lying around that you can use for that trick, but you can just use the sharp edge of any piece of steel that you have. It'll do the same thing. When I was happy with how the blade looked both in thickness and geometry, I slapped the file guide back on and I cleaned up the flat transition. I wanted it to be a perfect 90 degree and I wanted them to be the same height on both sides of the blade. If you're testing for your journeyman in the ABS and you do flat plunges like this, you have to make sure that they're even. They're probably going to fail you if they're not. On to one of the more nerve-wracking parts of this blade grind. A Bowie really needs to have a swedge for me to consider it a Bowie, and that's what I'm doing here. I'm doing it freehand. I know a lot of people use a table and a jig, but I just kind of find it really satisfying to do it by eye. Don't worry, I use my height gauge to ensure that I'm cutting the same amount of material off of both sides, and I ensure that the center of the blade still continues through the very tip. Because I now have a disc sander, I can use it to clean up all of the flats on my blade, including the swedge, and that's what I'm trying to do here. In theory, this should help me cut down my hand sanding time by almost 80%. I can skip an entire grit, and I can start with 400 grit, and the scratches will be less deep. However, getting used to the disc sander was very, very difficult. I didn't expect it to be so finicky. The disc sander spins both up and down, so if you're sanding a large surface, you sort of have to put more pressure on one side of the blade in order for it to not go flying at your face. When Beaumont Metalworks sent me this machine, they also sent me some sandpaper with some adhesive on the back. When I run out of these, I'm going to have to use the same sandpaper I use for hand sanding, but also use a spray adhesive. After getting the blade up to a 400 grit disc sanded finish, it was time to prepare for a step that I've never really done before.
Okay, this is a little sus, but I believe it's gonna be steady enough.
What I'm doing here is I'm using the mill to mill a shoulder right next to the back of the ricasso. This will make fitting up the guard to the back of the ricasso infinitely easier, and I definitely should have used a carbide end mill here because the high-speed steel did not cut. I ended up switching to carbide in between shots.
Oh, look at that. That is beautiful. I'm pretty sure the high-speed steel just like ended up dulling and just like making a lot of friction.
At this point, the Tang was around 0.28 inches thick, so I had to take 0.15 of an inch off either side. That would leave me with a Tang that was exactly 1/4 of an inch thick, and I could standardize the side of slot I needed to make in the guard.
Look at that shoulder. It's perfectly straight, and it's perfectly crisp. And if I do that on both sides, and then grind the Tang down to the thickness of this, there will be zero gap between my guard and the blade. Okay, so I've sat down, I did some planning on what I want for the handle. I think we're gonna be doing stainless guard, stainless spacer, wooden handle block, and then a stainless butt cap that's gonna be held in with like a takedown screw. I've never done it on a Bowie or a chef's knife without like adult supervision. So it's gonna be interesting to see if I can actually pull this off, but I think it'll look really, really cool.
If you've never seen this construction done on a knife before, it might be a little bit hard to visualize, and honestly it was for me too. I didn't really know what the butt cap was supposed to look like. I spent a lot of time trying to think about it, but I ended up having to phone a friend. I asked my friend Colton Arias what I should do, and he helped point me in the right direction. To prepare to carve the slot on the guard and the spacer, I was going to scribe some more lines. Technically with the mill, I don't have to, but it's a good way to visualize what I have to do, even if it's not what I'm going to be using to measure. I decided to use a carbide drill bit that was only 1/8 of an inch big, half the size of the slot. I heard from a bunch of people that doing the entire slot at once, as opposed to drilling a bunch of holes and removing the shmoo, was a much better thing to do. And I was really surprised because I could barely feel any resistance from my spindle.
That was so easy.
Here I was just taking a 20 thou depth of cut and going across the entire thing until I got through the whole thing.
I think 20 thou was too easy. I'm gonna do 25 thou.
Carving this slot was actually really cathartic because usually I would have to do this all with hand files, but now I can just spin a spindle on my mill and the slot sort of just appears. It was really amazing.
Whoa, there's zero resistance.
I was super surprised at how easy it was to turn the spindle on the sideways cut. I was fully expecting more, but this makes sense because it's an end mill.
Oh my gosh, that took all but, what was it, 30 minutes? And I have a slot, look at that. Do you know how beautiful this is? Oh. What?
It was very obvious that the thickness of my Tang was perfect for the width of the slot, but the corners of the slot didn't match up to the cross-section of my Tang. Basically, as you can see here, the roundness of the corners means that it won't line up perfectly with the cross-section of my Tang, so I'm using a square file here to get them as square as I can get them. When the guard was fitting most of the way, it was time to hammer it on and mechanically try and fit it to the shape of the Tang. At first, I thought that this was a little bit scary, but after thinking about it, there's actually no way I could hurt the blade, so I just went on with it.
When I take this off, I should see like shiny spots that tell me where to remove material. Alright, how do I take this off? Oh shit. Okay, funny story. My guard is now stuck.
If you didn't see what happened there, the end of my Tang actually got bigger and mushroomed because the material wasn't super solid. What I'm doing here is I'm cutting off that bad material and welding on some fresh, clean material. It may look like that this will make the Tang weaker, but it actually doesn't really change the strength at all. The Tang isn't necessarily a load-bearing part of the blade, and I'm making sure to take all precautions to make sure it's one solid piece of steel.
Oh my gosh. We're not quite there, but that's pretty damn good. I think that took less than 50% of the time it usually takes. I'd be happy to be here in like a day, so...
With the guard mostly fit, it was time to start carving the slot on the spacer. This is the piece that sits right under the guard, and I did it pretty much the exact same way as the guard, so I'm not going to show you too much of it.
I'm actually very confident about this fitting, because my Tang tapers very, very slightly, which means, some filing on the corners, and I think it'll basically fit perfectly. The metal is speaking to me like a Disney princess, but only for like inanimate objects. You know, that's not bad, all things considered.
With the guard and the spacer now essentially perfectly fit to the Tang, it was time to start worrying about the handle. This beautiful block of wood that I'm cutting into here is called Ambonia burl. It's got really rich color and awesome figures, so I was super excited to use that as the handle.
My math is right, those should be exactly an inch apart. Just kidding, I did know math, but they're still an inch apart.
Even though I have this fancy new mill, the way that I carve the slot in the handle block is going to be mostly the same. That's because most of my end mills are super short, and I don't really think you can get the longer end mills without paying an arm and a leg. But yeah, essentially, I'm just using a drill bit here and drilling a bunch of holes right next to each other. I was going to try something new with this mill though, and I would be drilling the holes a little bit closer together. I think that with the rigidity of the body, I would be able to drill them closer and not have them overlap. I was super surprised when I saw that the drill bit didn't wander at all. I think it's because the drill bits were new, but even still, that's never happened to me before. I decided to limit test the drill bit, and I tried to use it like an end mill. And the thing is, it kind of worked perfectly. There was zero webbing left behind. Once again, because the slot is rounded due to the shape of the drill bit, I had to make it square, and the tool of choice for that is something called a handle broach. It's basically a modified file that I just took to the grinder and ground some square corners on. It's not the best at it, but it still does the job.
Preliminary, let's see if it even goes in. Oh! You know, that's the good part about having a Tang that's like perfect thickness. Look at that. It doesn't want to go in, but it goes in.
The fitting was going okay at this point, but I knew that at some point in the future I was going to have to thread the end of my Tang. So I was going to grind out the profile of that now to make fitting the handle block a little easier. I also had the option of cutting a lot more off the Tang and then just welding all thread to it, but I wanted to do it this way because it was more easy to think about intuitively. I was going to be using this permanent marker trick to find out where the wood was contacting the Tang. Basically, wherever the permanent marker was removed, I would have to remove part of the wood.
Let's see where we're contacting. Okay, we're contacting there. There really is a big difference between like filing randomly and hoping that it fits to knowing exactly where you have to file. What? You already can't see any like light through there. Oh, it's off by 2 millimeters. Oh my god, I just used metric. We're off by 1/8 of an inch. Let's fit everything together. Oh my gosh. All right, moment of truth. Zero gap all the way around. You can see the tang, or the future tang nut.
With the 3 main pieces of the handle now fitting, it was time to actually make a spacer for the pommel. I decided to throw some extra color into the back of the handle, and I decided to use a piece of brass for that. This spacer is also going to have another use, which is to help me line up my hidden lineup pins. Because this spacer was going to be at the end of the handle, I only needed to drill 1 hole for the connection point. It definitely would have made my life a lot easier if I slightly oversized this hole. You'll see what I mean later on.
Alright, I think this tool is a deburring tool, which is super nice. Oh yeah, look at that. You see, nobody makes tools like this, which is like crazy, because anybody would buy this.
After drilling the hole in the spacer, it was time to drill the hole in the pommel. And once again, I only needed 1 hole, but later I was going to have to drill a little shoulder around it. My tool of choice for this was going to be an Anvil because I wanted the shoulder to be square. If I used a drill bit, it would have been angled inward, and I don't think it would have had the same effect as like a square shoulder. When that was done, it was time to start drilling the lineup pin holes in the spacer. I actually blundered and I drilled them on the wrong axis the first time, but that wouldn't matter because none of this would see daylight.
Alright, the cool thing is that these holes are so perfectly sized that even the burr keeps it from going in, which will ensure that all the pieces are lined up perfectly.
Now, the Bowie that I'm making isn't really a takedown because I'm going to be gluing everything together later, but in order to make sure that when I take it apart and put it back together for grinding, these pins were very essential.
Alright, if my math is right, and it always is, that was a joke. Pin goes in there, pin goes in there, then this. Look at that. Now whenever I put this on, it can't turn, it can't do anything.
With the holes in the spacer as a sort of guide, I drilled the lineup holes into the pommel cap. I wanted to make sure that all 3 of these pieces were perfectly aligned all the time.
Wait, that's so cool. That's the whole fixture? Oh my god, that's so beautiful.
With all of that done, it was time to start working on the pommel nut, the thing that's going to hold everything together. And in order to make that, I needed to use a lathe, but I didn't have one, so I went on a trip to Turner's Warehouse again. This here is Chad. He's the owner of Turner's Warehouse, and he knows his way around a lathe. He was going to be helping me make this entire pommel nut. And the first thing we did was draw out exactly what I needed to make, just so we had an idea. This beautiful machine right here is called the South Bend lathe. It's older than my parents, but it still felt so smooth. You don't really even feel this kind of quality in modern tools, so it was really, really cool to both see and get to use it. After some thinking, we decided to use brass as the material for the pommel nut. I thought that it would match the color of the spacer, and it was a lot easier to machine.
This is the lock for the tailstock. When drilling, it's good to hold this, especially in the start, because it'll try to spin. So as we advance it, you don't really have to pull it all the way out, just back it up. Because what you don't want is chips to pack in the end.
The order of operations that we were going to use to make this piece was we were going to first drill the hole, as you saw there. Later, we were going to be tapping the inside of this hole so that it could hold on to some threads that I was going to put on the tang later.
It's like staying centered because it's like going in now.
Mm-hmm. Yeah, once you're started, it should be good.
This step was actually a little bit stressful because if I cranked on the tap a little bit too hard, it could get stuck in the brass piece, and we would have to completely restart. I also didn't really have a frame of reference for this because it was my first time ever tapping a hole.
But always take half of what you think you want, and maybe even a little less till you measure it and make sure it's doing what you want.
Okay.
Because it's real easy in your brain to be like, 5, and then you're like, oh, I did 5, but I meant 2.5, or I meant 2.
I did that on the mill where I forgot the diameter of the mill bit, and
Yeah.
it went over. So
Yeah, and that'll play a factor too, especially on the mill.
The next step was to turn down the thickness of this brass piece. The outer diameter of the nut was 3/8 of an inch, so I had to turn it down to exactly 3/8 of an inch. One cool thing about this lathe is that it had this auto feed feature, and that was really cool, but I had to keep watching it or else I could accidentally cut into the chuck, which would be really, really bad. With the outer diameter perfectly turned down, it was time to start turning down the inner one to 1/4 of an inch. But the thing is, we had to use a different cutter because the other one didn't really fit.
Oh my god, it's so beautiful.
With the different radii perfectly turned down, it was time to use a different cutter and cut the entire piece off. I thought that we would have to dig around in the chips to find the piece, but apparently I could just hold it as it was being cut off, and it worked perfectly.
Oh yeah. WD-40 is all the time. Like, works for it.
With this piece finished, it was time to go back to my shop and start to put everything together. The first thing I had to do was I had to turn the end of this pommel nut into a flathead screw. This would make it so that I would be able to actually screw it onto the end of the tang.
I need 0.138 before I can start threading it. And right now I'm at 0.215, which means I have a long way to go.
This grinding process was actually really awkward because the end of the tang isn't square with the rest of the blade. It goes downward. So I had to really awkwardly turn the entire thing.
Just a little bit of lube.
This is actually only the second time in my life that I've used one of these threading tools, and you can see here in my movements, I'm super awkward and I was really scared that I wasn't going to cut them square. The technique that I decided on was a full spin clockwise and then a quarter spin counterclockwise to break the chip. I've seen a lot of people do this in their YouTube videos, and I thought I might as well follow them because I don't really know what I'm doing.
Oh yeah, nice and smooth coming up. I think that means we have good threads. Theoretically, everything should be perfect. Garden spacer, block. And this will go in here. How are you pressing unevenly on the butt cap? I think I know exactly why this isn't working. And I think it could be as simple as the disc sander is not square. You see that. You need to take a little bit of material off one of the sides. Okay, I fixed it. Look how beautiful the fit up is now. Born from blood, sweat, and tears. Perfectly flat, no play in anything. Like, this is a technically finished knife without an edge. It just looks like shit because nothing is shaped, but it's actually pretty cool. I'm really tired, but I think it's pretty awesome.
Everything turned out super well, but it took a lot longer than it looked like on camera to get this all set up. I think it took me 4 hours to get it fit up. Now it was time to move on to some finer details, and the first thing I'm going to be doing is hand sanding the blade. I was going to be starting with 400 grit because I got up to 400 grit on the disc sander.
Wait, this is actually going to save hours. Like full-on, fully fledged hours.
Every once in a while, I get a new tool in my shop or I try a new technique that's essentially a quantum leap in my making process. This was definitely one of those leaps. It usually takes me around 10 hours to fully sand a blade to 400 grit, especially of this size. But overall, this took me like 2 hours to do both sides.
Yeah, that corner is going to take a little bit to clean up, but most of the blade looks pretty good. I hate this back section. I can't reach it with the disc grinder, so I just need to get all of the scratches out manually.
After doing the flats of the blade and getting them up to 400 grit, it was time to worry about the spine. Once again, the Damascus for this blade is a Mosaic, so the spine has a really interesting pattern. I needed to get both the spine and the swedge up to the same quality of 400 grit finish that I got the flats to.
Oh gosh, my back hurts. I need to go roll on the lacrosse ball for like 10 minutes.
With the main parts of the blade sanded to 400 grit, I needed to start sanding it on the ricasso, but before I did that, I coated the entire blade in a thing called fluid film so that it wouldn't rust while I sanded the ricasso. If you've made it this far into the video, there's actually a really good chance that you aren't subscribed. If you're enjoying the video so far, consider subscribing. It's free and you can always change your mind. The blade is currently at a 400 grit hand sanded finish, and I was going to be going up to 600 grit later. However, this is the perfect time for me to etch my maker's mark into the blade. The method that I'm using to etch my name into the blade is something called chemical electro-etching. In the future, I want to do this with a laser, but this is all I have for now.
Where's the best place to put this?
maybe here.
I got this machine off Amazon a couple years ago. It's called the Personalizer Plus. It works really well, but it was a little expensive. I think if you want to mark your own blades at this time, I would just make your own device.
All right, let's check the depth. If it's not deep enough, I'll do it for longer. Yeah, we need more depth than that. There we go. Nice and deep.
I decided to do the name on both sides. I thought it would be better to have it be semi-symmetrical.
Oh yeah, nice, even, deep etch. That's what we like.
With the maker's mark now etched into the blade and looking nice and pretty, it was time to start shaping the handle. But before I could do any profiling or anything, I had to make sure everything was on the same reference plane. So I took the height gauge, scribed a bunch of lines, and ground everything to the same plane that was referenced off the thickness of the blade. These days, whenever I grind wood, I like to have some sort of dust collection running. I really don't want to have to breathe in that much wood dust. But the thing is, my dust collector got clogged, and I tried to hook up my shop vac instead. But that also got clogged, so I ended up turning my backyard into a toxic wasteland. Everything that I said about blade profiles applies to the handle profile as well. One of the interesting things is that the line of the spine of the blade has to continue straight through the top of the handle. If you don't do that, it really does look kind of weird. The number of lines that I'm scribing on the guard here might seem a little excessive, but they're really important to ensure that I grind perfectly symmetrical. If I only ground the horizontal lines, I wouldn't really have an idea of where the curves start or end, so that grid-like pattern is also really important. I decided to go for a leaf-shaped guard. It was very, very simple, but it was kind of hard to execute because the flow of the lines needed to match the flow of everything else. One cool thing that I was going to try to do on this build was I wanted to do an heirloom fit from the front of my handle onto the spacer. That means that the shape of my spacer has to be smaller than the front of my handle, which means I also had to envision what the handle was going to look like before I even shaped it. I wanted the dimensions of my pommel cap to be dependent on the dimensions of the spacer. I wanted the front of the handle to taper backwards and get bigger as you got toward the base of the blade. That way, if you were swinging it, it wouldn't come flying out of your hand. And that's what these scribe lines are derived off of. When every part of the handle was shaped except for the handle block itself, I decided it was a good time to start working on the sheath of the blade. The sheath that I was planning to make for this massive Bowie wasn't necessarily a sheath that is meant to be carried. Like I mentioned before, this Bowie is meant to be a display piece. It wasn't meant to be carried around and used. I like to think of this sheath as just the show of thanks to my client for trusting me with such a big piece. It may not look like it, but this one piece of paper will allow me to trace 4 separate parts. First, I'm going to sketch the outlines of both big sides, and then I can simply trim off the sandwich pieces, giving me the other 2 pieces of the sheath.
Alright, I'm trying to use up as little leather as possible.
This sheet of leather was 9 to 11 ounces, which means it was really, really difficult to cut.
Oh god.
One of the benefits of cutting out this much leather with these scissors is that you get a really big thumb pump. I didn't even know I had that much mass in my hand, and it was kind of interesting.
You got it, buddy? Oh, you got it? Oh. Too slow. Ooh.
I wanted this sheath to contrast with the bright and shiny aspect of the handle, so I was going to be dyeing it jet black. I needed to do the inside of the sheath here because after everything was glued together, it would be really, really difficult to actually dye the inside. I also had to make sure to dye the insides of the welt because that's also on the inside of the sheath. When it comes to gluing 2 pieces of leather together, I think contact cement is the best option. The bond that it creates is really strong, but it also stays flexible for as long as you need it to, and this is really important because you don't really find leather sheets that are as hard as rock. The one downside of the contact cement though is that it smells really bad and lets off some pretty disgusting fumes, so I decided to do this in the garage and with the respirator. One cool thing about this contact cement though is that it's activated by contact, so if you hammer it, the bond becomes a lot tougher. Just like how I have to profile knives, I also had to profile the sheath. the little welts in between the main faces of the sheath were a little bit oversized, and I needed to grind them down to match the level of the outside pieces. This will make it so that I can easily align everything when I need to glue it together for the final glue up.
It's full of like crumbs of leather from the grinder. Oh well.
It would be a little boring if I left the sides of the sheath with no texture, so it was now time to texture it. One thing that I learned from reading your guys' comments was that it's super important to wet the leather before patterning it. This would make it so that the marks were a little deeper and contrast a little more with the flat spots. Last time I textured my sheath, I only used one type of punch, and it looked cool, but I wanted to level it up a little bit. So here I'm using this little scallop clam looking thing and combining it with the pattern I used last time. Getting the spacing even was definitely the most difficult part, but as I kept going on, it got a lot easier.
I got a little close to the edge there. Okay, how the fuck am I gonna do this tip? Alright. I think that's all I'm gonna do for like the scalloped one. And I'll just continue this one all the way to the tip.
Making this sheath was definitely really satisfying and probably one of the most fun parts of this build. If you don't have the facilities for knife making, I highly suggest getting into leatherworking.
Alright, that's one side. I hope this looks cool when darkened.
One interesting thing that I didn't know about leather before I started using it was that it doesn't really come colored. Every single leather piece that you see with color, that's probably dye. It's not like the original leather.
I might need to do multiple coats. It's not looking super dark. This is the best marker that I've ever used. Wow.
When I was satisfied with the color of the sheath after multiple coats, it was time to permanently glue everything together. This second layer of contact cement wasn't really any different from the first one. I just didn't plan to rip it apart later and instead thread everything together. For this final glue up, I had to be super careful to align everything together perfectly. If I didn't put them together the right way, the knife wouldn't fit in, and I had to make sure. With the sheath permanently glued together, it was time to start punching the holes for the threads later. And the only way I could do this was by hand. I didn't have a machine to do this, and I had to do it across the entire side of the sheath twice. I had the freedom of potentially doing only one row of stitching around the outside, but this sheath and the blade were a package deal, and I wanted the durability of the sheath to at least meet the durability of the blade, which was already really high. This process was extremely satisfying, but it was also really loud. I needed to go to the garage and grab my earmuffs so that I wouldn't have my ears be ringing. The tool that you're supposed to use after this punch is something called a stitching awl. It's supposed to enlarge the holes a little bit so that you can get the thread to actually pass through. I heard from your guys' suggestions that the drill press was actually a lot faster and easier, so that's what I used here.
This is going swimmingly.
It was super important for these holes to go directly to the other side and meet the stitching line. If they didn't, it would look really, really weird. So for some of these, I had to angle the sheath to make sure they went straight.
I'll do like 8 lengths for this first side. He wants it, but I'm not gonna give it to him. Hey! Stop!
The type of thread that I'm using to stitch this sheath together is a dark, waxy thread. It is obscenely durable, but the only downside is that it's so thick that I have to pull it through the other end with pliers sometimes. The reason that I wore these gloves was so that when I hand tightened the thread, it could be as tight as I could get them. The only thing is that they were really thick and it was hard to actually get any tactile feel, so it kind of felt like I was trying to scream underwater.
Alright, after 14 years, I'm 1/8 of the way. Not even 1/8 of the way. I'm like 1/10 of the way. You know it's gonna stay together when it's almost impossible to get the needle through in the back stitching.
Now, with a quick cleanup of the sides of the sheath on the grinder at a high grit, it was time to darken the sides and then burnish them.
Oh yeah. Really does bring it all together. Okay, look at that. This side gives like elegant. This side gives lazy.
With the sides darkened, it was time to get ready to burnish them, and I had this little bottle called gum tragasanth that's supposed to help with the burnishing, and I just put some on a shop cloth and I wiped it on the sides.
Right now I just...
I realized at this point that the sheath was a little bit tight for the blade, so what I was going to try to do was I was going to try to wet form the leather to the shape of the blade. I'm sure there's more professional ways of doing this with like foam presses and stuff, but this was the best I could come up with at the time. I wrapped the blade in saran wrap so it wouldn't rust, and then I wet the sheath, put the blade in, and then I sandwiched it in between 2 towels. I let this sit for about a day until the leather dried, and then it was time to go back to the handle.
I have All-Star stuck in my head. All-Star from Shrek.
Off camera, I had the time to design and implement a new dust collection setup. My old dust collector actually broke, so I got a new one, and I recreated everything from scratch. In theory, it should work for both wood and metal. All I have to do is toggle the metal one on and off. From what I can see so far, it works really, really well, but I sort of have to limit test it and actually throw some heavy sparks to make sure that it works. Onto what I'm actually grinding though, this is the first time I've ever shaped the ends of my handles with the contact wheel. I scribed out the outlines of the end cap and the spacer, so I knew exactly what shape I needed both sides of this to be. This is the first time I've ever shaped the handle like this. Usually I shape every part of the handle together, and I have to give a shout out to JVB Knives for his wonderful videos on making his own Bowies that inspired me to shape a handle like this. When I was mostly satisfied with the shape of my wooden handle, it was time to direct my attention back to the end cap. The goal was to actually just dome the end of it so that it would flow better into the handle. A blocky end cap wouldn't really look that great, and that scribe line is just meant to show me where the dome was going to end. At this point, I was only using the friction from the lineup pins to hold this end cap to the handle, and I decided instead I wanted to screw it to a scrap piece of wood. It gave me a lot better of a grip, and it helped me shape it without worrying about damaging the handle. But yeah, with all parts of the handle now awaiting their final polishing, it was time to finally etch the blade.
I fear I may need the chair.
Before I can etch though, I have to make sure the blade is up to a 600 grit hand-sanded finish, and I also have to darken my maker's mark.
Oh yeah, super, super dark.
The stuff that I'm using to darken is just permablue from Birchwood Casey, and what I'm doing here is I'm sanding down the flats so that only the text itself was darkened and everything else was shiny.
Hey, it's my name.
It's extremely important to go into the Damascus etch with a very, very clean blade finish, and I also need to make sure to wipe off all of the oils. So I'm using some Dawn dish soap and scrubbing it multiple times just to make sure that it's clean.
Okay, 2 minutes. Wait, I'm like kind of nervous. I hope like... Okay, let's... Oh my gosh! Wait.
I knew that with how excited I was to see just the first ferric chloride etch, I knew that with a nice coffee etch and a nice layer of Carnauba wax, it was going to look really, really insane. For as long as I've been making Damascus, my etching process has been mostly the same. I dip the blade in ferric chloride, and then I clean off the oxides with 2500 grit sandpaper. If you've never seen this process, you're probably wondering why I'm wiping off all of those dark colors. Doesn't the Damascus look better with more contrast? But the thing is, the ferric chloride etch is only meant to give me my depth. It gives me those ridges and valleys that you see in Damascus. The way that I actually get my color is through a process called the coffee etch, and it's exactly what it sounds like. I take my blade and I dip it in some instant coffee for around 4 hours.
This kind of reminds me of 8th grade chem or 6th grade chem, where we had to like rinse out the test tubes with distilled water 3 times.
When I first tried to do a coffee etch, I didn't know a lot of the minutiae of the process. It looks deceptively simple. The thing is, there's a few things that you really have to avoid. The first of which is that you can't use tap water or drinking water, you have to use distilled water. If you use any other water than distilled water, the minerals in the water will interact with the coffee and it might not give you the perfect etch. Another thing that you have to watch out for is that you can't etch for too little time. Sometimes it can be deceptive and the wet finish looks incredible. And then you wipe it clean and then it looks a lot less dark than you thought it was.
Here we go. Oh, 4 hours. Check in at 4 hours.
While the blade was darkening, it was the perfect time to finalize my fittings. What I'm doing here is I'm actually doming my spacer. I didn't want it to be perfectly square because that wouldn't really look quite right. I made sure to break the corners first so that when I went to round it on the Scotch-Brite wheel, everything would be symmetrical. When I got to the finest grit of Scotch-Brite wheel that I had, I actually put some green buffing compound on the wheel. This would help grind out some of the scratches and help get everything just a little bit more shiny. When that was done, it was time to finalize the guard. My guard had very sharp corners at this point, and I decided to use my disc sander and angle the table to get them so that they were perfect all the way around. This is the part that was going to be contacting the top of the client's hands, and I didn't want them to accidentally hurt him. After this was done, I spent a lot of time on the grinder finalizing both the handle and the pommel cap. I wanted every part of the handle to eventually be mirror polished, so this was super important so that I wouldn't have to hand sand for around 10 hours. And speaking of hand sanding, this was the only way that I could find to actually hold the guard so that I could sand it. Every other method was going to end up scratching the guard, so this was really the only option. When I first started making knives, I believed that the buffing machine was essentially cheating. But now that I've used it for a couple years, it's definitely not. You have to do a lot of hand sanding before you can start using the buffer, because if you buff a non-fully hand sanded finish, it'll just look streaky and disgusting.
You know, that's not too bad.
The spacer went pretty much exactly the same as the guard, but what I'm really excited to show you guys is the polish that I got on the handle block. My process for this was mostly the same at the start. I went from 400 grit to 600 grit, but once I went up to 1500 grit is where things were different. Usually I don't lubricate the wood whenever I sand it. However, this time I decided to put some of the blade oil that I usually finish my blades on it when I was sanding. I didn't expect it to do too much, but it actually made the finish so much deeper and so much richer.
Dude, it looks like fire.
I mentioned earlier that I was going to be doing an heirloom fit on this, so I did that with my file and some 600 grit sandpaper. After meticulously grinding that heirloom fit, it was time to buff the handle block. Something interesting happened and the buffing compound stuck to the outside of the block. I was a little bit scared at first, but luckily it was really easy to wipe off and everything was okay.
I've never gotten a finish like this. This looks so good. Oh my god. Oh.
I'm willing to bet that most of you guys are curious to see what the coffee etch turned out like, so I'm gonna glaze over the last bit of the final polishing and let's go look at the etch.
4 hours later. Please be good, please be good.
Oh! It looks good everywhere except for where it doesn't. That makes no sense until you see it.
The entire face of the blade is like perfect contrast. Then you get to the spine and you see it's like a lot lighter. And it's also lighter on the bolster right here. And I think I know what the problem is. What did I use to contact the tip? I was on the buffer like this. I think there's like buffing compound on there that I didn't get off. And I don't think the coffee could get to it. Okay, I'm gonna sand off everything and re-coffee it. Kinda sucks because everything is literally ready for the glue up. Except for the most important part. It pains me because this really is like a pretty beautiful finish. That sucks. Oh, it's pretty durable too. Like it's much thicker than the ferric. Okay, we're 2 hours into the next coffee etch. I hope to see no splotches. I don't really know what to do if there are. Okay, that already looks like a billion times better. There's zero splotchiness. It looks good. I think I'm gonna let it go the full 4 hours and then take it out.
Luckily, the second coffee etch turned out a billion times better than the first one, and we got 100% coverage on the entire blade. Once I went over the entire blade with some sunshine cloth, it was time to do a new finish that I've never shown you guys before. It's the Carnauba Wax Finish. Generally, when you think of wax, you think of candle wax, that soft stuff that just burns and gets super soft. Now, I want you to take that and just throw it out the window. Carnauba wax is entirely different. It's so hard that you can't even touch it with your fingernail. And that's one of the properties that makes it perfect as a blade finish. Another thing that it does is that it actually darkens the blacks in the Damascus even more. So Carnauba Wax both enhances the look of the piece and it protects it. I wish I was brave enough to try this finish a little bit earlier because it really is the perfect finish for high-end knives like this. With a nice thin even layer across the entire blade, the finish is a little bit hazy. But one of the cool things about Carnauba Wax is that it's hard enough that you can buff it, and that's what I'm doing here with the Sunshine Cloth.
This buffed Carnauba Wax is literally the same thing as Blacktail Studios N3 Nano, but for metal. It's so good. Oh my gosh. Look at that contrast. Look at that polish. What else could you want on metal?
After bringing the wax up to a really high polish, it was time to finally glue everything together. I made sure to clean all my pieces and my blade tang to make sure that the glue would adhere properly to the metal. If you're gluing a knife together, I highly recommend that you use toughened epoxy. It is much more resistant to moisture changes, and after it cures, it has just that little bit of play, which means that your blade will hopefully not crack. I didn't bed my handle block, so it was super important that I had that tape at the end so that the epoxy would have 100% contact with the tang itself. As you can see here, if I didn't have the tape there, the epoxy would probably just flow out the end of the handle and maybe not touch the tang in some parts. To ensure that my pommel cap and spacer were put on the right way, I actually left indent marks on them. That way I knew the perfect orientation to put them in and that they wouldn't go on the blade backwards, because that would be really, really tragic. When the pommel nut was fully tightened, there was so much pressure in the handle that the epoxy was seeping out from basically every orifice. It was super important for me to clean every single one of these with an acetone dipped Q-tip. 24 hours later, when the epoxy was fully cured, it was time to cut off the excess material on the pommel nut and grind everything flat, and finally, the piece would be finished. And believe it or not, up until this point, I hadn't yet seen the blade fully assembled, so that anxious feeling that you're experiencing right now, waiting to see the final piece, I was feeling that too.
I'm kind of scared. Oh my god.
I genuinely think that this Bowie is currently my magnum opus. Even though I planned out the entire Damascus pattern and sketched every single forge weld, the final product still blew me away. The stars and explosions in the Damascus were so crisp and clear, and the coffee etch and Carnauba wax finish was just magnificent. The thing about this blade that I really do think is the best part though is the handle. I'd never attempted a pommel nut construction before this, and having done it in this piece, I can see myself doing it many more times in the future. The Ambuena burl handle came out looking incredible, so rich in color with amazing figure, and the shiny silver fittings with the brass accents really do complement each other. There's probably a good chance that you, the viewer, are probably wondering what I'm going to be building next. I mentioned it in my last video, but the next project I'm going to be working on is actually Sichelschmidt from One Piece, the Black Blade. I can't share too many details about it just yet, but just know that I'm going to be treating the build with utmost care and respect, and that I really want to make it like I pulled it straight from the anime itself. Regardless, I hope you enjoyed watching this video, and I hope that at some point in the future, you'll consider giving this video a rewatch. I'm sure that there's one or two things that you didn't fully catch, and that you'll fully catch the second time. Just like every other blade that leaves my shop, I had to make sure that this Bowie was as sharp as I could get it. I actually got an entirely new sharpening setup just for this blade. This green stone you see right here is actually a diamond stone, and it's one of the best stones I've ever used. I also got 2 new leather strops loaded with diamond lapping pastes, and the difference between this paste and green buffing compound is just night and day. It produces such a fine edge, but it also retains its toothiness, which I thought was really interesting.
You're the thickest part of the glove. But yeah,
don't forget to click the link in the description to get the special discount that CyberGhost VPN is offering to you. For only $2.03 a month, which is frankly crazy, CyberGhost will protect your data while you browse and grant you full access to a lot of blog content on the internet. It's entirely risk-free, so I highly recommend you check it out in the link in my description.